The James Webb Space Telescope, JWST, stands as one of the most revolutionary advancements in modern astronomy, capturing the attention of scientists, enthusiasts, and the general public alike. Since its launch and activation, it has provided us with breathtaking new perspectives on the cosmos, opening a window to parts of the universe that were previously inaccessible. The awe-inspiring images and data it has returned to Earth continue to deepen our understanding of the cosmos. But beyond the stunning visuals, many may wonder how they, as non-professional astronomers, can engage with this monumental scientific tool. Can regular people actually use the JWST for their own exploration of space, or is it strictly the domain of highly trained professionals? The surprising answer is that yes, even everyday space enthusiasts can harness the power of this remarkable telescope. Let's take a deeper dive into how the JWST works, its purpose, and how you could potentially participate in unraveling the mysteries of the universe. To understand what makes the JWST so special, it's crucial to recognize its unparalleled capabilities. Often compared to the Hubble Space Telescope, which was launched in 1990, the JWST exceeds its predecessor in significant ways. While Hubble gave us spectacular images in visible and ultraviolet light, the JWST takes us even further by focusing on infrared light. This capability opens up an entirely new realm of exploration. For instance, the JWST can peer through dense clouds of dust and gas that obscure much of the universe in visible light. These clouds, often found in regions of star formation, galaxy growth, and other key cosmic phenomena, can hide from traditional telescopes like Hubble. But by focusing on infrared light, which can pass through such materials, JWST allows astronomers to study areas previously inaccessible, offering unprecedented views of the universe's evolution. Additionally, JWST's focus on infrared light makes it uniquely suited to study the early universe. Light emitted by the first galaxies that formed after the Big Bang was in the ultraviolet and visible ranges, but over billions of years, the expansion of the universe stretched this light into the infrared. By capturing this ancient, stretched light, JWST provides a window into the early stages of the universe, allowing us to study galaxies that existed just a few 100 million years after the Big Bang. This ability to look back in time is not only fascinating but also crucial for scientists seeking to understand the universe's origins and how it has evolved over billions of years. The creation of the James Webb Space Telescope was an ambitious and lengthy endeavor. After the success of the Hubble Space Telescope, astronomers quickly realized that there were still limitations to what they could observe. They needed a telescope that could push the boundaries further and capture even more distant and faint objects. Thus, the idea of a successor to Hubble was born. Originally referred to as the Next Generation Space Telescope, NGST, the project aimed to develop a larger and more sensitive telescope capable of making groundbreaking discoveries. The team envisioned a telescope with a massive 8-meter mirror, much larger than Hubble's 2.4-meter mirror. This would allow the JWST to collect 6 times more light, making it far more sensitive to faint and distant objects. But constructing such a large mirror posed numerous technical challenges. To fit into the rocket that would launch it, the mirror had to be designed as a foldable structure that could unfurl once in space. This was no small feat, and it represented just one of the many challenges the JWST team faced. Beyond technical issues, the project was also plagued by delays, budget overruns, and political hurdles. The telescope's cost eventually ballooned into billions of dollars, and at one point, its budget consumed a full quarter of NASA's entire budget. Some lawmakers even considered canceling the project altogether. Despite these challenges, the scientists and engineers behind the JWST persisted, and after years of setbacks, the telescope was finally completed, launched, and deployed flawlessly. Today, it sits at the Earth-Sun Lagrange Point 2, L2, a position about 1.5 million kilometers from Earth, capturing unprecedented images and data from deep space. What truly sets the JWST apart, however, is its arsenal of advanced instruments. These instruments include the Near-Infrared Camera, NIRCam, Near-Infrared Spectrograph, NIRSPEC, Mid-Infrared Instrument, MIRI, and the Fine Guidance Sensor/Near-Infrared Imager and Slitless Spectrograph, FGS/NIRS. Each of these tools plays a vital role in unraveling the mysteries of the universe. NIRCam, for example, is primarily used for imaging distant galaxies and studying their formation and evolution. NIRSPEC, on the other hand, can take spectra of multiple objects simultaneously, allowing scientists to analyze the chemical compositions of stars and galaxies. MIRI operates in the mid-infrared range, making it perfect for detecting colder objects, such as dust clouds and faint galaxies. The FGS/NIRS, meanwhile, aids in stabilizing the telescope and conducting spectroscopic observations of exoplanets and their atmospheres. The scientific goals of the JWST are equally ambitious. One of its primary missions is to study the earliest galaxies that formed after the Big Bang, providing crucial insights into the formation of the first stars and galaxies. These early structures hold the key to understanding how the universe transitioned from a relatively uniform set of particles into the complex cosmos we see today, filled with galaxies, stars, and planets. By studying these ancient galaxies, JWST allows us to peer back in time to the very beginnings of cosmic history. Another key mission of the JWST is the study of exoplanets, planets that orbit stars outside of our solar system. With its infrared sensitivity, the telescope can observe the atmospheres of these distant worlds, potentially detecting the chemical signatures of life. This could answer one of the most profound questions humanity has ever asked: are we alone in the universe? The journey doesn't end with scientists and professionals. You might be surprised to learn that you, too, can participate in JWST's mission. One of the most exciting aspects of the telescope is the General Observer, GO, program, which allows researchers, professional or otherwise, from around the world to propose their own observations. If you have a well-thought-out idea and can demonstrate why the JWST is the perfect tool to accomplish it, you might be awarded time on the telescope. Writing a successful proposal isn't easy, however. You need to provide a detailed explanation of your scientific goals, why the JWST is necessary for your project, and how you plan to conduct your observations. The competition is fierce, but if your proposal stands out, you could get the opportunity to conduct real science with one of the most powerful telescopes ever built. If your proposal is accepted, the process doesn't stop there. You'll need to submit a Phase 2 proposal, detailing the specific locations in the sky you want to observe, the instrument settings, and the exposure times for each observation. Precision is critical, as even small errors can result in wasted telescope time. After the observations are complete, you'll have exclusive access to the data for 12 months. Once that period ends, the data is made available to the global scientific community through the Mikulski Archive for Space Telescopes, MAST. For those not ready to tackle a full-fledged proposal, there's still a way to engage with the telescope's findings. All of the JWST's data becomes public after a certain period, meaning that anyone, scientist, student, or amateur astronomer, can access it. Even without submitting your own proposal, you can still dive into the vast troves of data JWST generates, exploring its findings and perhaps even making discoveries of your own. This makes the JWST an incredibly collaborative tool, one that invites people from all walks of life to participate in its mission of discovery. Beyond individual research, the JWST also participates in legacy programs, which generate valuable data sets for the entire scientific community. These programs often focus on well-known areas of the sky, but the JWST's capabilities allow it to reveal new insights into these familiar regions. For example, the famous Hubble Ultra Deep Field, which captured over 10,000 galaxies in a seemingly empty patch of sky, has a counterpart in the JWST's deep field observations, such as the SMACS 0723 cluster image, which holds the record for the deepest infrared image ever taken. Legacy programs like these provide data that can be used for years to come, offering countless opportunities for discovery. If you're interested in exploring JWST's data but don't know where to start, there are numerous resources available online to guide you. For instance, popular astronomy channels and websites provide tutorials on how to download and process the telescope's images, allowing you to create your own color composites of distant galaxies and other celestial phenomena. Even if you're new to astronomy, these resources make it easier than ever to engage with real space science. In short, the James Webb Space Telescope is not only a tool for professional scientists, but also a gateway for the general public to explore the universe. Whether you're a dedicated researcher, an aspiring astronomer, or simply someone with a passion for space, there's a way for you to get involved. The telescope has opened the door to a new era of discovery, and now that it's fully operational, the possibilities are endless. So, whether you're submitting a proposal, downloading data, or simply following the latest JWST news, the opportunity to be a part of this historic mission is within reach. You never know, you might just make the next groundbreaking discovery.